Hey folks, welcome to Vology's Wireside Chats. I am your host Neil Terracciano, and I am on a part 2 session. We kind of didn't plan for this, sort of uncovered some of the features I like to call a mousetrap of SimpliVity. It makes it very unique and unlike any other converged solution. We're going to try to make this one around 10 minutes if we can. Sure. So I'm going to give an opportunity to focus on this data virtualization platform, this piece that really separates SimpliVity, honestly, from any storage solution on its own, let alone a converged solution, because there's a really interesting value there. In long and short of exactly what this layer performs, Ron, is it allows for me to create a deduplication aware or a data aware layer across my cluster, across my data center, and then even across the federation to some degree, right?
Yeah. So the data virtualization platform is our file system coupled with the piece of hardware that we call the OmniStack accelerator. And both of those pieces together provide inline deduplication, compression, and optimization of all data across all tiers locally, across all sites globally.
Okay. So the important piece here is that it's on a card that's separated out. Absolutely. So we're not utilizing a virtual machine to do the deduplication piece per se, right, where all the horsepower is needed. But we do have an appliance in there that's doing something, right? There's some kind
that's running our file system, keeping track of where everything is. But if you were to try and do inline deduplication with just Intel processors, you would need hundreds of them.
Right.
So we've actually created a PCIe card that couples with that file system in our virtual controller that offloads just that dedupe compression optimization workloads from the Intel processors inside of each node.
Okay, and so before the naysayers say, whoa, how much horsepower, what's typical sizing for this little, you guys, what do you call it, a controller?
Yeah, our virtual controller.
Your virtual controller.
Yeah,
so what's our typical sizing?
It's 4 vCPU per virtual controller, which you have one per node. And then the RAM that we use varies based on the actual model that you use.
Okay, so it's really not that big. And then whatever value it's providing, obviously, is giving access. So the RAM, for instance, that it might be using, it's not that it's taking this RAM from the environment, it's actually applying this RAM to the environment. So it's not a negative effect, it's more of a positive effect. Okay, Ron, so we're going to give you as little possible time as we can to tell us as much as you can about this mousetrap that makes you guys different than everybody else.
Okay, awesome.
So you have some slides for us?
Yeah, so if you want to take a look at the slide deck, right, an OmniStack system is just simply a 2U server. It's got some CPU, it has some RAM, it's got an SSD pool and an HDD pool. Each OmniStack system is running ESX on it, so you can think of each OmniStack system as an ESX host as well. We have some VMs, but in the center sits our data virtualization platform. It's our file system. And we couple that with the OmniStack accelerator, again, that PCIe card that offloads all of that dedupe compression optimization inside of each system. We put those together. We present our data stores unified across all the OmniStack systems within a logical data center over the 10 gig network out to the ESX hosts. Below that, we call it our data management layer. That's, again, our file system and OmniStack accelerator. Now, as we start to see unique writes, brand new writes, we've never seen them come in, we're going to actually register those writes at our data management layer. It's totally unique, so we can't deduplicate it. So we'll actually compress that in our hardware and write it directly to the back-end spindles. As we start to see other unique writes come in, you'll see the exact same thing happen. We'll actually compress them and write them to the back-end spindles.
Right. Nothing unique happening here yet, right?
Well, aside from the compression in hardware. Okay. Right? Again, we're offloading that compression from the Intel processors as well. That, surprisingly enough, is an extremely CPU-intensive operation. Right? If anybody has created a zip file versus just extracted a zip file, the creation takes a lot longer,
that compression takes a lot of horsepower. That's very true.
We're actually offloading that as well. Now, as we start to see duplicate writes come into the system, and it doesn't matter what VM or application they're coming from, it's in one entire pool within that data center, we will see that deduplicated at the data management layer on our card in RAM, and we'll never write that block down to the back-end spindles. Right? So we're doing inline deduplication versus post-process. If you think about post-process, you're waiting some period of time.
Right.
You've had to land all of your data there during that period of time, reread all of that data back into memory, again, using up hard drive IOPS, taking that away from your production environment. processing all of that data and then removing that data from the environment. Oh, by the way, you now have to do a garbage cleanup and defrag on the back end. Right? Again, impacting your production environment. Mm-hmm. We're doing all of this inline, removing all of that workload from the environment.
So there's no go back. There's no
go back. All of the data when we write it to the back end spindles is actually sequentialized. Again, saving all of that defrag work from the back end.
So you're holding that again in this layer, in this area, so that you can do a sequential layout and essentially really conserve what available sectors I may have, right, Absolutely. On a spindle or on a given platter.
Yep.
So is there a defrag process for this?
There's not one needed.
I don't have to defrag.
And, you know, if you delete data from the environment, sure,
we might have to lay it out again. Yeah. But as far as when it writes,
it's going to be much more efficient, right? Because we're not landing a tremendous amount of data on the back end and then reading it back out.
Where's all your hashing data held? All your information about where things are and the pointers. Is that written on the spindles, or
no, that's in our virtual controller. Metadata is stored on the virtual controller as well as the SSD pool.
So we're not scattering it through the disks and drives like ZFS likes to do. This is pretty consolidated and high performance. So I noticed that there's an SSD layer, and I might be getting ahead of it, Ron. It doesn't seem like we're touching that one yet. What's the SSD layer for?
Yeah, so the best way to think about the SSD pool is it's just a very large read cache. So we're skipping that, writing data directly to HDDs. Right? SSDs have a very low wear factor in them, so we just use those for reads. So as a read comes into the environment, it's pulled either from cache on the virtual controller, so RAM, or it's pulled from SSD. So your reads are going to be extremely quick as well.
How much SSD percentage-wise do you typically see in comparison to the rest of it, just so people get an idea for how big the cache is?
It just depends on the model that you choose and the size SSD
large
that
chunk.
you choose.
I mean, give me the range of SSD tiers you might have in it. So the 2200 is your smallest. So that's 400s or 200s in it?
That'll have dual 400 gig drives mirrored, so you're looking, what,
so we get 400 gigs of read cache.
Yep. Now keep in mind that read cache is all entirely deduplicated as well. So we're just pulling 4K or 8K blocks into that read cache one time, and you can.
So I may only be grabbing 1 out of 10, really, right?
Right.
So my hit rate, my ratio, my cache hit rate is going to be extremely high when it comes to the SSD. That's going to be amazing. So the ratio of SSD to spindles is kind of blown up as a result of that. What kind of I/O? I know you like sticky kind of.
Sure.
What kind of I/O should I expect out of your smaller box?
Yeah. So the numbers we throw around are pretty conservative. 20,000 IOPS per node.
Out of one box.
One node. Yep. And as you add more boxes or nodes,
I get a pooled effect, right? A linear scale.
It's going to scale exactly linearly. Yep.
So let's talk about that piece, right? Because this is very interesting. You know, this write caching that's happening and deduplication. It's a combination I don't think we've ever seen before.
Yeah.
This is just on the host, right?
Yeah. So as we see more writes come in, and as we speed this up, you're going to see a tremendous amount of I/O happening at the data management layer, right?
And this is all just in the PCI bus now, right? So that's way faster even than SSDs.
Absolutely. Yeah. So all the writes are being acknowledged at that layer once they've been persisted across multiple nodes, right? And that's important. We are persisting your data across multiple nodes to protect it from failure. Once it hits these accelerators, we're acknowledging that write back to the application so that it can continue with its work. Then we're sequentializing the I/O, writing it to the back-end spindles. And what you can see from that example was a tremendous amount of I/O happening at the data management layer, but very little I/O having to take place to your back-end spindles. So if you think about traditional infrastructure, we've had to architect these environments with many, many more spindles than we actually needed for our capacity, just so we could hit our performance numbers. Since we're removing all of those redundant writes from the environment, we don't have to architect that way anymore.
You know, that's an interesting point, Ron, right? Because typically, folks, if you look at this slide and we were to visualize the path that a data block might happen in a traditional environment, not only am I going to pass through all of this, I may actually end up traversing, or I will be traversing, a network.
Absolutely.
And then coming all the way back. Yep. So every single one of those hops is adding latency to my read and write and to my performance. And then the other interesting piece here is that most of it is happening on the NUMA node, where the PCI card exists, which is incredibly fast. So how about that for data locality, right?
Yeah.
I mean, that's a pretty big deal to be able to read and write and then most of the time, we'll say, I don't even leave the PCI bus for most of my writes.
Yep.
And then if I'm not so lucky, I go down to the spindles. Tell me how this works, though. This is just one host, right?
Yeah.
How does this work in a cluster or in a data center? Is there a level of awareness or integration?
Yeah. So as we, obviously that data management layer and data virtualization platform spans a single site, but it also spans multiple sites as well, right? So every OmniStack system in what we call a federation, which is just a group of OmniStack systems, understands the blocks that all of the other OmniStack systems own. So we've deduplicated all your writes for your primary storage, right? Increasing performance there. But now once we've deduplicated that data, we never duplicate that data again. So if I want to do a local full backup, which, oh, by the way, we have that built in as well, all we have to do is simply create a full logical copy of that VM and metadata. We never duplicate that data once it's stored, so your local backups are going to be 0K, right? What does that do for you? It doesn't produce more I/O when you're running your backup, so you're not
doesn't produce any, right?
0. So you're not going to impact your production environment, right? You're going to get back all of that time that you've had to wait and not run batch jobs or other high-intense jobs during those backup windows. Right now you can run a true 24/7 shop running all of your intense workloads without having to worry about protecting your data and managing around that.
That's amazing. So there is a level of awareness for this metadata that is, say, cluster-wide or data center-wide?
Federation-wide.
So back up to a slide for me real quick. I want to see this layer that you show us that's eating up a lot of our I/Os. I just want to make sure I understand that. That layer exists on the entire infrastructure, or is it just one host machine? This level of awareness, is it just on that one machine you're showing me? Or do I have that metadata awareness, because you're calling that federated, right? Mm-hmm. So that metadata awareness exists how wide?
It's federation-wide, right? And
so if I have two data centers like the demo we did earlier, mm-hmm. they're aware of the metadata that exists on both. So I don't really need to write. So that's how we're moving these terabyte machines or these half terabyte machines in less than a minute.
Absolutely, yeah, and that's one of our inventions.
Why send me something I already have,
exactly.
Right? There was a saying you used to give us when you first started presenting this, and we all weren't believing you about what this thing could do. What was that? The best I/O is the one we never had to have, right?
The best I/O is the one you don't have to do.
Right. So
Amdahl said it.
I don't know how many storage solutions I put together where I'm trying to hit 60, 70, 80,000 I/O. I wonder how many I would need if I didn't need them.
Yeah.
Right?
Yeah.
That's an interesting one. So folks, that really does give us a very unique opportunity to show some of the value that SimpliVity has, is this deduplication effect. But there's a big asterisk here. And please take this with a grain of salt. Yours might be better than this in your environment, or it might not be as good. But to be honest with you, I've found you to be somewhat conservative recently with the deduplication rates. Deduplication rates, touch on those real quick before you finish up.
Yeah.
The one you showed me was at 65.
Yeah, so we're going to give you a number of dedupe ratio for your primary data is 1.5 to 1 and 1.5 to 1 for compression. So we're going to be extremely conservative. Now, once you run your first backup, again, since we never duplicate data, it's 100% deduped. So the more backups you have, the higher your dedupe.
Greater impact of rate of deduplication occurs.
Yeah, absolutely.
So we can get into the hundreds?
Yep.
Right. Yeah. That's amazing. I got to see that. So, all right. So go ahead. I don't mean to interrupt you.
Oh, no worries. Yeah. So
finish your lesson on the magic behind it.
Great segue, because that's an important part of our technology. It's one of our inventions that we actually patented, was the ability for all of our OmniStack systems to share and understand the metadata that all of the other OmniStack systems have. So if we want to do a remote backup, if the analogy I like to use here is, if you think of each virtual machine as a Lego set, right? Each Lego set has an instruction book, right? The instruction book here is synonymous with the metadata for a VM. So we simply send the instruction book across the wire to the OmniStack systems at the other data center. They already know what blocks already exist at that data center, so it's going to compare them against that instruction booklet and then just pull the unique blocks across to make a full logical backup of that VM at that other site. So again, We're deduping at the 4K to 8K block level. Those remote backups, even if we've never done one before for a VM, are going to be compared against all the blocks that already exist over there. So we're only going to send those unique blocks across the wire.
So this controller brings a whole nother level of awareness of the data that exists on its platform.
Absolutely.
And says, essentially, right, that I'm not going to allow traffic that's not necessarily, I don't want the same car to park here twice.
Exactly.
Right?
Yep.
So essentially, if you send me another red Chevette, then I'm not sending another red Chevette over there. I've got it. No matter what that data is being used for.
Cross-exchange, SQL, Oracle, if it's the same 4K or 8K block, we're never going to send it.
What about a customer that has a multi-tenancy environment for different departments? Are they limited to the data that they have, or are they going to have access to the data?
It's going to be across the entire pool.
So if I have the accounting department and the dev guys that like to blow up my stuff, and then I've got, let's just say I've got 3 or 4 other SQL machines, and then Larry's department, it's very needy. So Larry's gets the efficiencies through the deduplication efficiency on this whole virtualization platform layer.
Yep.
From the all the tenants.
Yeah, as long as they're all within the same federation, they're all.
As long as they're federated.
Yep.
So
going to be part of each other.
I can separate a multi-tenant environment and still get the economical or the whole ecosystem of deduplication, because we're not going to write the same 4K of ones and zeros ever again.
Exactly.
That's. Do you know anybody else that does that?
Nobody.
I don't.
Nope,
And my job is to know guys that do that, right? I don't really know anything else that's like that, to be honest with you. And when I see it in production, right, we're used to seeing it, like you said, right, post-process. There are some inline guys, but they're DR targets. Right. They're not converged solutions. Yep. There are some converged solutions, and they claim to have localized data. I don't know that it's NUMA local. I don't know that you can get any closer than that, right? If it's not in RAM, it's not as local as you guys are.
Exactly.
So that's really impressive to me. And this use case and the value that's associated with this, plus the fact that we're able to move these machines back and forth in a federated environment with incredible efficiency, I just don't understand how it hasn't come up sooner than this.
Yeah, and so we've been at it for 5.5 years now. We started in September 2009, created this technology, wrapped all of our patents around it, and now we're the only ones that have it.
It's really
because we're able to do that. So backup is great, inline dedupe is great for your primary storage, but if you're doing backups, you have to be able to restore, right? We wanted to make those just as efficient. So when we do a restore, all we have to do is create another logical copy of metadata. Again, we don't duplicate that data. We have the same blocks on the back end. We present that VM up through vCenter. The customer's able to do whatever it is they wanted to do with that VM.
You're sending a recipe to a controller that already has all the ingredients.
Absolutely.
And it's just essentially going to say, I've got the eggs, I got the milk, I got all this, here's your bread, and we're finished. Don't go to the store and get all this stuff.
Absolutely.
In every other solution I've ever dealt with, we have data to write.
Yep. You're mapping volumes and LUNs and doing all sorts of different stuff. With us, you don't have to do that.
So are you a storage genius?
I am not.
So I can tell you that from a storage perspective, I've done this for quite a while. It would take a lot of work for me to design something that would be even remotely close to performing the same results. But I can tell you the steps to achieve. Maybe with lots of orchestration and lots of script writing, maybe I could get there.
Don't forget the millions of dollars.
And the millions of dollars. There's that part too, right? It's kind of important, isn't it?
A little bit.
It's really amazing stuff. I'm really excited to see how this turns out. This is really something that nobody else has, guys. And so, folks, if you can't feel the level of excitement I have, every time I really get to focus on this, I'm more and more really just absolutely amazed at what this thing's capable of do. And it's one of those things, it's the real deal, it's great when you have that moment and go, why didn't anybody else think of it, right? It's really that good. I understand this federated deduplication, this awareness of deduplication that's bringing a great deal of benefit, and it's single-handedly removing us from the need, for some of the even biggest enterprise scenarios. You guys have some big customers on this?
We do, yeah. Some of the largest customers in the world.
Any Fortune 500?
Fortune 30.
Fortune 30.
Yep,
okay, great. So maybe we have some buy-in, right? There's some trust with this.
Yeah.
Is it on a trusted platform?
Yeah, so we have Cisco UCS as well as the SimpliVity platform that we've OEM'd from Dell.
The Dell solution is the one that we've had some experience with.
Yep.
We certainly do. We're much bigger friends with that side of the SimpliVity box. The OEM box comes kind of out ready to shoot, and I already know the models. We kind of know where the storage capabilities are on those, so we typically would go in that direction. You guys offer all the support that's associated with the box too.
Yep.
All right, folks. Well, listen, I only got so much time with Ron, but I hope that you found this little piece very helpful. This is the mousetrap that makes SimpliVity, outside of the great people they have working for them, obviously. This piece here is what really is the key differentiator between any converged solution. I couldn't even design a converged solution by the time that you got it. It might look converged by then, but it's not going to have. It just can't have those kinds of features. So we're very excited to see how this can fit in everybody's environment. Ron, we can fit this into an environment for almost any project, for any purpose.
Absolutely. To
slowly permeate in and possibly take over once they get an opportunity to get a feel for whether we're full of crap on this thing or we're not. And that's really what you've got to go through. We do have a POC program available as well. For those of you that are very serious about evaluating the platform, we do have options where we can get gear out to you, and as long as it hits those validation and some of the requirements on the proof of concept, then you would own the gear. And I'm sure that if we meet all the objectives and the price is right, then game over, right, folks? So please be sure to reach out to your account manager. We can get you a personal demonstration, kind of go over some of the things that are maybe unique to your environment and the needs that are unique and pain points that are unique to you. And then go over some of this stuff with you to see how it would fit into your environment, whether we sneak in on a small basis or whether we go in there and look at your next forklift upgrade for server and compute, or one or the other, and see if that'll fit. So please don't hesitate to reach out to your account manager. Myself, Ron, and your account manager be very, very willing to help out. Until then, folks, thanks for tuning in, and we'll see you on the wire side.